So now we will see application of relative velocity in two dimension. Now see in this topic, we have to study different cases, like for crossing the river, crossing the flowing river. You might have seen when the river is flowing, and if you want to cross by following the shortest path or by taking the shortest time, you have to swim in the different way. Suppose if you want to cross just river, to reach to the opposite bank, and in what way you can reach, everything we have to study here under the application of relative velocity. Now see here, we will be studying the velocity of the river with respect to ground, velocity of the swimmer with respect to ground, and velocity of swimmer with respect to river. So now first condition is crossing the river, along shortest path. Suppose you have taken river like this, these are the two banks of the river. River is flowing in this direction. So velocity of river we can take velocity of river with respect to ground to this side. Now this is the point A, and now you have to reach to the point B. So this is the shortest distance to go to the point B, but you will have to swim to this side. If you are swimming here to this side at certain angle theta, so that you are reaching at the point B. So the velocity of swimmer with respect to river we can take with respect to still water is VSR. So now we can calculate velocity of swimmer with respect to ground, it should be along this. So here we can take one vector like this will be representing VRG, and you can also make the parallelogram here like this, but the magnitude of VSG can be calculated. VSG is equal to under root of VSR square minus VRG square. This is the velocity of swimmer along AB. So now the swimmer will be crossing the river along this. We can also calculate time. So the time to cross river you can take simply AB is equal to, that is the shortest distance, divided by this one, we can write under root of VSR square minus VRG square. So we can calculate time also. So now this is the first application, crossing the river along the shortest path. Now we will see crossing the river by taking the shortest time. So second application is here, crossing the river in shortest time. Again we can take the same example here. These are the two banks of the river. River is flowing to this side. So velocity of river with respect to ground to this side here. This is the point A. Suppose a man is swimming along this. He is making his strokes normal to the flow of river. So this is velocity of swimmer with respect to ground, with respect to river here. Now he won't be reaching at this point to B, he will be reaching somewhere at the point C. And this will be a velocity of swimmer with respect to ground. This angle theta here. So we can calculate magnitude of VSG is equal to under root of VSR square plus VRG square. Here we can calculate time. T is equal to, we can write distance AB divided by, we can write here magnitude of VSR. This will be the time. If you know this time, you can calculate this distance BC. It means how long he has been taken away along the flow of river. So you can take BC is equal to, you can write here VRG into T. So, these are the different parameters which we have to calculate in this. So, this is the second application. Now, we will come to the third application. This is a very common example you might have seen. Suppose if it is raining and you are riding bicycle on the road, you will find you have to hold the umbrella in different directions. You have to change the direction of the umbrella, but if you are stationary and rain is falling vertically downward, you have to hold the umbrella just like this. But if you start moving, you have to change the direction of the umbrella. So, now this third application is relative velocity of rain, with respect to man. Now, I am taking an example. This I have taken the vertically up and down direction, and this I have taken, suppose this is east and this you have taken as west. Suppose a man is cycling to this side, that is the velocity of man, that is obviously with respect to ground. Rain is falling vertically downward, it means velocity of rain with respect to ground is to this side, velocity of man with respect to ground is to this side. Now, I have to calculate relative velocity of rain with respect to man. So, we will apply the simple concept of the simply relative velocity. So, we will superimpose a vector to this side, that is minus Vmg here. We have got these two vectors which are acting at 90-degree angle. Now, we will do vector addition. The resultant will be somewhere here. This is the velocity of rain with respect to man. This angle is theta. So, here we can calculate velocity of rain with respect to man, because there is two vectors, this and this, angle between them is 90 degree. So, we can write velocity of rain with respect to man, its magnitude is under root of velocity of man square plus velocity of rain square. Now, we can also calculate angle theta. We can write here tan theta is equal to Vm divided by Vr. So, now if you know this theta, you take this side, just proceed here, this angle is also theta. So, you have to hold the umbrella in this direction. The rain you will find here like this. So, initially if you were standing, you were finding the rain was falling vertically downward, but if you start cycling to this side with the certain speed, then you will find the direction of the rain with respect to man keeps on changing. That means relative velocity of rain with respect to man keeps on changing according to the speed. And whatever is the direction of the rain with respect to man, in that direction you have to hold the umbrella to protect yourself from the rain. Now, we will be doing examples related to all these topics which we have done in vectors.